Imagine trying to figure out if a new chemical formula is going to cause a severe human skin rash.
Right.
But instead of, actually looking for a rash on the skin, you extract mouse lymph nodes, break them down, and literally make them glow in the dark like fireflies.
It sounds completely like science fiction.
Right. It sounds bizarre. But this bioluminescent process is actually a global regulatory standard.
It really is a remarkable piece of scientific engineering. And, for you listening, this is highly relevant because you have an exam coming up on the exact regulatory document that governs this whole process.
Exactly.
We're talking about OECD Test Guideline 442A. So our mission for this deep dive is to basically serve as your personal study guides. We're going to break down the Local Lymph Node Assay, specifically the DA modification, so the LLNA. DA.
Yeah, and the ultimate goal here is testing for skin sensitization.
Yeah.
Which clinically translates to allergic contact dermatitis.
Right, exactly.
And for a long time, the industry standard for this was Test Guideline 406, which relied on guinea pigs. And the thing with that test is it required actually waiting for the animals to develop severe, visible allergic reactions on their skin.
Yeah, which is obviously not ideal. So following that, the original LLNA, which was Test Guideline 429, shifted the focus to mice, and it looked at the lymph nodes instead of the skin, which was a massive improvement for animal welfare.
Definitely.
But the huge catch was that it relied heavily on radioactive isotopes to measure the cellular response.
Oh, wow. Yeah.
Yeah, and that created an enormous, just a massive logistical and safety burden for laboratories worldwide. Purchasing, handling, disposing of radioactive materials, it's incredibly restrictive.
Which brings us to the document that you, the listener, are actually being tested on.
Yeah.
OECD 442A. It provides a way to test for skin sensitization that avoids the severe skin reactions of the guinea pig models and completely eliminates the need for radioactivity.
Exactly. It's a huge win on both fronts.
But before we get into the mechanics of making cells glow, which is just so cool, let's look at the underlying immunology. Because, if the end goal is to prevent a human skin rash, measuring lymph nodes seems kind of counterintuitive.
Right.
Wait, if we are trying to figure out if a chemical gives a human a skin rash, why are we looking at mouse lymph nodes instead of just looking for a rash on the mouse's skin?
That is the big question. And the answer really lies in distinguishing between the induction phase and the elicitation phase of an allergic response.
Okay, break that down for us.
So the elicitation phase is the visible rash. That physical symptom only occurs after the immune system has already learned to identify a chemical as an enemy and launches an attack.
So the elicitation is like the downstream consequence.
Exactly. The induction phase, however, is the initial learning process.
Yeah.
So when a chemical allergen penetrates the skin, specialized immune cells capture it, and then they migrate down to the local draining lymph nodes.
Right.
And they present that chemical antigen to the T lymphocytes. If the immune system decides, hey, this is a threat, those specific lymphocytes begin multiplying rapidly to build up an army.
Wow.
And we call that rapid multiplication lymphocyte proliferation.
Okay, so this assay basically intercepts the whole process at the induction phase. Yeah. By measuring the proliferation of the lymphocytes in the nodes, we are observing the immune system preparing for a reaction.
Exactly.
Meaning we don't actually have to wait for the tissue damage to occur on the skin.
That is the absolute core premise of the assay. We're quantifying the biological preparation for an allergy rather than waiting for the allergy itself.
That is so clever. Okay, so understanding that we're tracking cell multiplication, we need to examine how the DA modification actually counts those cells without, using radioactive tagging.
Right.
Because DA stands for Dasyl Chemical Industries, right?
Right.
They're the developers who figured this out. And their solution basically bypasses cell counting entirely by measuring adenosine triphosphate, or ATP.
Yeah, and since you're already studying immunology and toxicology for this exam, you know that intracellular ATP concentrations correlate really tightly with the number of living metabolically active cells.
Because it's the energy currency of the cell.
Exactly. Every living cell has ATP. So when lymphocytes proliferate in the draining auricular lymph nodes, and by auricular I mean the nodes situated near the ear where the chemical is applied,
right,
the total population of living cells spikes, and consequently the total volume of intracellular ATP in that tissue sample spikes right along with it.
So ATP is simply our proxy for immune cell proliferation.
Yes, exactly.
But to measure that ATP, the DA modification uses bioluminescence. It utilizes a luciferin and luciferase reaction,
Yeah,
which is just wild to me.
it really is. It's the exact same chemical pathway utilized by fireflies.
I love that.
Yeah, so for your exam, you need to visualize the components of this reaction. You extract the ATP from the proliferated lymph nodes, then you combine it with luciferin and oxygen. Then the enzyme luciferase is introduced to catalyze the whole reaction. And the output of that specific combination is light.
Light. That's just so cool. And the emitted light intensity is linearly proportional to the ATP concentration, right?
Yeah, completely linear.
And a luminometer captures this light, providing a readout in relative luminescence units, or RLU.
Right, RLU. And to conceptualize this, think of it like assessing the occupancy of a massive office building at night.
Oh, I like this.
Right. Rather than walking floor by floor and opening every door to count individual employees, you just stand out in the parking lot and measure the total amount of light radiating from the windows.
Because more light equals more people.
Exactly. A higher total light output reliably indicates a higher number of people working inside. In our assay, more light means more ATP, which indicates more immune cells, and that confirms the chemical actually triggered a sensitization response.
That makes so much sense. But wait, if we're relying on a luciferase reaction, background bioluminescence must be a total nightmare.
Oh, absolutely.
Because, I mean, every living cell has ATP. How do you distinguish between a massive immune response to a chemical and just the natural, everyday baseline cell turnover glowing in the luminometer?
That is the major challenge, and it requires really rigid control over biological variables. Starting with the specific test subjects, you can't just use a random sample of mice from a pet store.
Right, obviously.
The guideline strictly mandates the CBAJ strain of mice.
Because outbred mice would have, way too much immunological variance. Like, one mouse might naturally have highly active lymph nodes while another one doesn't.
Exactly. That would create massive fluctuations in your baseline light. The CBAJ strain is highly inbred and characterized by a really robust, predictable Th1 and Th2 immune response.
Okay, so it standardizes the background noise.
Right. This genetic uniformity minimizes that background noise in the lymph nodes. Furthermore, the guideline stipulates the mice must be female, nulliparous, which means they have never given birth, and non-pregnant.
Because hormonal fluctuations from pregnancy or previous gestations can drastically alter immune sensitivity, right?
Yes. You got it. Hormones play a huge role in immune response.
And I also saw they have to be young adults, specifically between 8 and 12 weeks old at the start of the study. And they need to be group housed and acclimatized to the laboratory environment for at least 5 days.
Yes, because stress affects the immune system too, so they really need time to settle in before you start applying chemicals.
Makes sense.
Okay.
So controlling the animal genetics and environment stabilizes the baseline, but we still need experimental controls to establish our mathematical reference points.
We do.
And the negative control, which is known here as the vehicle control, or VC, serves this purpose because the test chemical needs a vehicle to actually be applied to the skin.
Right.
The recommended vehicle is a mixture of acetone and olive oil in a 4.1 volume ratio. So the vehicle control group receives only this mixture. No test chemical at all.
Exactly. That sets our background light level. It tells us basically how much the nodes naturally glow when exposed strictly to the solvent. And then on the flip side, we need a positive control. And this is just to prove the lab technicians didn't botch the luciferase reaction.
Right. You have to prove the system works.
Yeah, so the positive control utilizes a known moderate sensitizer. The guideline recommends either 25% hexylcinamic aldehyde or 25% eugenol.
Okay.
So if a laboratory runs the assay using 25% eugenol and the luminometer does not show a significant spike in light, well, the laboratory process is fundamentally flawed. The assay has failed its validation for that day.
Okay, so having established the subjects and the baselines, we need to talk about the timeline because the actual dosing procedure is highly specific. And let's be honest, it is frequently tested on exams.
Very frequently.
So the chemicals are applied to the dorsum, or the back of the mouse's ears, but there is a mandatory preparation step involving a 1% aqueous solution of sodium lauryl sulfate, or SLS.
Right, and you have to understand why we do that. The stratum corneum, which is the outermost layer of the skin, is a formidable barrier. It's literally designed to keep foreign substances out. Now, SLS is a surfactant, like what you'd find in soap.
Okay, yeah.
So painting the ear with 1% SLS disrupts the lipid bilayer of that stratum corneum. It essentially dissolves some of the protective oils in denature's surface proteins.
Oh, I see. So it subtly compromises the barrier to ensure the test chemical actually penetrates down into the living tissue below rather than just, sitting harmlessly on the surface.
Exactly. You apply the 1% SLS, you allow exactly 1 hour for it to alter the barrier, and then you apply 25 microliters of your test substance.
And the schedule for this application is super distinct. You dose on days 1, 2, and 3. Then there is a total cessation of treatment. You skip a few days, and then dose again on day 7. Finally, day 8 is the harvest day.
Race.
So for exam purposes, listener, I want you to remember this phrase, 1, 2, 3, 7 dose. Day 8 diagnose.
That's a great mnemonic. 1, 2, 3, 7 dose. Day 8 diagnose. Days 4, 5, and 6 are crucial rest days where the animals remain entirely undisturbed.
I want to focus on that gap, actually. Because a student analyzing this schedule might wonder, why the weird gap? Why dose 1, 2, 3, skip a few days, dose on 7, and kill on 8? Why not just dose continuously for a week?
Right, it seems random, but we have to accommodate the biological mechanics of the induction phase.
Okay.
When the antigen is introduced on days 1 through 3, the immune system requires time to react. The antigen-presenting cells have to engulf the chemical, migrate through the lymphatic vessels, physically reach the draining node, and then interact with the T cells.
So that migration and the subsequent cellular replication, it just takes time.
Exactly. Those rest days are basically the biological cooking time. You provide the initial exposures to trigger the immune cascade, and then you step back to allow clonal expansion to occur completely unchecked.
Ah.
And then that isolated dose on day 7 acts as a secondary challenge. It's a booster that maximizes the cellular response just before you measure the absolute peak of that proliferation on day 8.
Okay, that makes perfect sense. So day 8 arrives, the nodes are excised, they're homogenized into a single-cell suspension, the firefly reaction is triggered, and we get our ROU light readings.
Yep, the moment of truth.
The next phase is scoring. How does a regulator look at those luminescence numbers and definitively categorize a chemical as a skin sensitizer?
So the metric used is called the stimulation index, or the SI. To calculate the SI, you take the mean RLU of your test substance group and simply divide it by the mean RLU of the vehicle control group.
So we were just calculating the ratio of the chemical's light output against the baseline background light.
Exactly, it's a ratio. And the regulatory threshold for a positive result is 1.8.
10.8.
Yeah. If the SI is greater than or equal to 1.8, the substance is classified as a skin sensitizer.
And to make that 1.8 threshold stick in your mind, think of an audio amplifier. If the baseline static of the system is an SI of like 1.2 or 1.5, might just be random biological noise.
Right, just a slight variation in how the mice felt that week.
It's exactly.
Yeah.
But decades of validation data have shown that an SI of 1.8 is the line where the signal distinctly and undeniably rises above that biological noise floor.
That's a really good way to think about it. An SI of 1.8 or higher triggers a positive classification. However, biology naturally resists absolute binaries.
Right, it's never that simple.
No, it's not. If a chemical produces an SI between 1.8 and 2.5, it enters this gray zone, which is defined as a borderline positive.
It's similar to like a blip on an air traffic control radar that is too small to definitively categorize as a commercial jet, but you also can't just ignore it and say it's a flock of birds.
Yeah,
You can't immediately trigger an alarm, but you need to consult other instruments.
exactly. The guideline explicitly warns against making definitive classifications based solely on a borderline SI. You have to evaluate the weight of evidence.
Like what?
Like, did the light intensity increase in a clear dose-response curve as the chemical concentration was raised? Is the SI mathematically significant, or was there just a really wide variance among the individual mice in that dose group?
Oh, I see.
You also have to analyze the structural alerts of the chemical itself. Does its molecular shape resemble other known sensitizers?
So the 1.8 to 2.5 range requires real investigative cross-referencing. Now, as straightforward as this bioluminescent proxy is, reading through the guideline reveals several critical vulnerabilities in the assay.
Oh, yes.
There are specific traps that can ruin a laboratory's data, and for the listener, these are prime targets for exam questions.
Oh, absolutely. Professors love to test on these. The most common physical vulnerability is the vehicle selection trap. This happens particularly when dealing with hydrophilic or water-loving test substances.
Right.
A tester might assume that, well, if a chemical is water-soluble, I should naturally dissolve it in 100% water for the application.
But the mouse's ear is covered in sebum and natural oils.
Exactly.
If you pipette pure water onto it, the surface tension just causes it to bead up and roll right off.
Oh.
The chemical never interfaces with the stratum corneum at all.
Exactly. It just runs down the mouse's face. The guideline expressly forbids wholly aqueous vehicles for this reason. If a substance is highly hydrophilic, the lab must utilize an appropriate solubilizer. And a really common choice is 1% pluronic L92.
Pluronic L92, it's a triblock copolymer, right? Which means it acts as a mechanical bridge. It has a hydrophobic core that binds to the skin's oils and hydrophilic tails that grip the water-soluble chemical.
Right.
So it effectively breaks the surface tension and forces the chemical to absorb. So listener, if an exam question proposes 100% water as a vehicle, recognize it immediately as a trap.
Yes, huge red flag. The second major pitfall is more conceptual. The LLNA DA utilizes ATP as the absolute proxy for cell count. But consider what happens if the test chemical itself is an ATP inhibitor or contains enzymes that actively degrade ATP.
Oh, wow. If the chemical destroys ATP upon contact, the luciferase reaction has no fuel.
Exactly.
The luminometer will record near zero light even if the lymph nodes are massively swollen with like millions of proliferating immune cells.
Yeah. Right. It creates a catastrophic false negative. The assay basically indicates the chemical is perfectly safe, when in reality, it is a potent sensitizer that has masked its own detection by disabling the testing mechanism.
That's terrifying. It's like a chemical erasing its own footprints.
It really is. The guideline explicitly states this assay is invalid for testing substances that inhibit or degrade ATP.
Okay, so that is a critical limitation to memorize.
Yeah.
False negatives are bad,
Yeah.
but we also have to watch out for false positives. Which brings us to the irritation trap.
Yes. We discussed earlier how the induction phase involves immune cells migrating to the lymph nodes. However, severe physical tissue damage will also cause a localized immune response.
Right, inflammation.
Exactly. If a chemical is excessively irritating, maybe it's highly acidic or acts as a severe detergent, it physically damages the epidermal tissue.
Okay.
So the immune system rushes cells to the local lymph nodes to manage the massive inflammation and tissue repair, completely independent of any actual allergic sensitization.
So the nodes swell, the ATP spikes, and the luminometer registers a massive SI score. But it's reacting to, like, chemical burns, not an allergy.
Exactly. It's a huge false positive. To prevent this, laboratories that lack comprehensive toxicological data on a new chemical will execute a pre-screen test on a small subset of mice.
Oh, smart.
Yeah, they apply the chemical and utilize a digital micrometer to actually measure the thickness of the ear.
Because ear swelling is a direct, quantifiable marker of acute inflammation.
Precisely. If the ear thickness increases by 25% or more compared to its baseline, or if visual grading of erythema, which is redness, scores a 3 or higher on their scale, the concentration is deemed excessively irritating.
And so they can't use it.
Right. The laboratory must reduce the dose concentration for the main study to avoid that false positive trap.
Okay, so 25% ear swelling is the threshold for excessive irritation. Got it.
All right.
Finally, there is a logistical trap that occurs on harvest day, the day 8 time crunch.
Oh, the time crunch is real. ATP is a highly volatile molecule outside of a living metabolizing system. The moment the animals is humanely euthanized and the blood flow stops, intracellular ATP begins to degrade rapidly.
So the clock starts the literal second the nodes are removed.
Yes. The guideline imposes a draconian timeline to preserve data integrity. From the exact moment the auricular lymph nodes are excised from the mouse, the technicians must homogenize the tissue, apply the lysis buffer to release the intracellular ATP, and execute the final luminometer measurement strictly within 20 minutes.
20 minutes from excision to measurement, that is fast.
It's very fast, and the total time from the initial animal sacrifice to that final reading cannot exceed 30 minutes overall.
Wow.
So if a technician processes a large batch of mice and the final nodes sit on the bench for, say, 45 minutes, the ATP degrades, the light dims, and the resulting SI scores are artificially depressed.
The timeline is absolute. Because biological degradation does not pause for laboratory delays.
Nope, it definitely doesn't.
Okay, we've dissected the mechanics of OECD 442A from the overarching immunological theory all the way down to the molecular volatility of ATP. So to ensure you, the listener, are fully prepared for your exam, let's synthesize this into the non-negotiable concepts.
Let's do it.
If you retain nothing else from this deep dive, these are the 6 core takeaways.
First, the LLNA. DA measures the induction phase of skin sensitization. It achieves this by quantifying ATP content via a bioluminescent luciferin and luciferase reaction, which operates as a non-radioactive proxy for lymphocyte proliferation.
Second, the biological baseline is controlled by exclusively utilizing young adult, nulliparous, non-pregnant female CBHA mice, capitalizing on their genetic uniformity.
Third, the dosing schedule accommodates the biological processing time of the immune system. Dosing occurs on days 1, 2, 3, and 7, with diagnosis on day 8. The gap allows for the necessary clonal expansion of the lymphocytes.
Remember, 1, 2, 3, 7 dose, day 8 diagnose. Fourth, the scoring metric is the stimulation index, or SI. An SI of 1.8 or higher classifies the substance as a positive sensitizer, while an SI between 1.8 and 2.5 requires rigorous cross-referencing against other data points.
Fifth, be hyper-aware of the assay's limitations. Wholly aqueous vehicles are forbidden due to skin surface tension. Chemicals that degrade ATP will cause dangerous false negatives. And excessively irritating chemicals, which is determined by a 25% increase in ear thickness, will trigger false positives.
And sixth, harvest day is a strict race against molecular degradation. Laboratories have a maximum of 20 minutes from the excision of the nodes to the final ATP measurement.
Mastering those 6 pillars provides a really comprehensive understanding of both the operational mechanics and the scientific limitations of the guideline.
Absolutely. And as you close your notes and prepare for this exam, consider the broader trajectory of toxicological science we've explored today. I mean, we've transitioned from observing severe blistering tissue damage on guinea pigs to utilizing hazardous radioactive isotopes to count cells in mice to this DA modification where we rely on the bioluminescence of extracted ATP.
It's an incredible progression.
We are moving progressively further away from observing the macroorganism and closer to measuring pure molecular cascades. So the profound question moving forward is this. If we map the ATP proxy and these cellular mechanisms with such absolute precision, wait, how soon until we could reconstruct this entire immunological induction phase inside a purely synthetic in vitro environment?
That's the dream, right? Rendering the animal models entirely obsolete.
It's a fascinating evolution of science. Good luck in your exam. You're going to do great.